Welcome to In 5 Minutes. Today our topic is Murray machine. Murray machine is a state machine in which output is defined for each state. As you will see here, there are three states S0, S1 and S2 for which output Z is defined in each state. As for S0 output is 0, S1 state output is again 0 and for S2 output is 1. Now we will see there is an exchange of states depending upon the inputs. If input x is equal to 0, S0 states will remain in S0 for input x is equal to 0, whereas it will move to S1 if x is equal to 1. S1 state will remain in S1 for x is equal to 1 and it will move to S2 state for x is equal to 0, and the state S2 moves to S0 for any input x is equal to 0 or 1. But all these three cases output is fixed with the state. So there are again three states, so we require two state variables. So we have taken variable A and variable B. So S0 corresponds to 0 0, S1 corresponds to 0 1, S2 corresponds to 1 0 and S3 corresponds to 1 1. Here S3 states it is not used. Okay, so we'll move down to the state table for the Murray machine. This is called as state table, in which present state are moved to the next state depending upon the input combination, and output is obtained for each state defined. So we'll start from S0. Let us consider that S0 is the reset state. That means whenever you will power on the circuit the machine will start from S0 state. So for S0 corresponds to AB 0 0. When x is equal to 0, it will remain in that state, therefore next state will be again 0 0 and output will be 0. Why? Because the output is associated with the state and the state is S0. So for S0 output is Z0 as seen in the state diagram. For the next combination input 1 for the state S0, it will move to S1. So S1 corresponds to 0 1. Again the output will be 0. This change in state, see there is a change in state from S0 to S1, but still the output is of the previous state. This output will be changed in the next state, while this next state 0 1 will move on here and work it as a present state. Then the output will be changed according to the next state. What are the next state we have got here, which will be coming as a present state here, and then we'll change the output. Okay, so for state S1, that is 0 1, this is state S0. For 0 1 state, if x is equal to 0, it will go to S2. S2 corresponds to 1 0 and output is 0. If x is equal to 1, it will remain in S1 state, that is 1 0, and the output will be 0. For S2 1 0, if x is equal to 0, it will go to S0 state and output will be 1. See, now for the S2 state output is defined, z is equal to 1. Till the time output was 0 in state S1, it was 0 in the state S0. When S2 state input is given 1, no matter what for the S2 state input is 0 or 1, it will go to S0 state. So next state will be S0 and the output corresponding will be equal to 1. So this is about S2 state. Once again here S3 state, which we cannot ignore. S3, it is not used for any input. Let us say input may be anything, that is we put a don't care there. Across corresponds to don't care. Next state will be again don't care. Depending upon any input, it can go to any output, any next state, but the corresponding output will be always 0. This is very important. Why? Because once again if you will not put it 0, the circuit will behave as anything. The output will be 1 or 0 and there may be a glitch in the circuit. That's why it is important to always put a 0 in the output for the don't care conditions. From this state table diagram, we can easily calculate the output. Since output is present only for these two states, and these two states corresponds to input combination A, B and X, likewise where X is variable, so you can easily cut down this part, and the common part remains is A is equal to 1, B is equal to 0. That's why Z can be directly written as A, B bar. No need to solve for the K-map. Further down you can calculate outputs of the respective K-maps for the next state table. If it is mentioned for JK, you can draw JAKA depending upon the present state and the next state. If you are asked to calculate through D-type flip-flop, it is very simple. You have to just copy this next table as the input to the D flip-flop corresponding to A and corresponding to B respectively. This is all about Moore machine. Thank you.